Rahim. Assalamu alaikum dear students. This is our next module. This is our next problem, next video, having been once again chosen from the same book which we are following for last many videos. Okay, book name is Modern Physics by Kenneth S. Crane. Okay, dear students, I have actually chosen 6 books of modern physics, and one by one, inshallah, we will cover all these 6 books. Okay, after this book, that is Modern Physics by Kenneth S. Crane, we may start modern physics by Arthur Weiser, then we may start modern physics by Raymond Moyer Moses, then we may start modern physics by Randy Harris, then we may start modern physics by Paul Tipler, then we may start modern physics by Stephen T. Thornton and Andrew Rex, etc. Okay. As usual, we first come to its statement. Okay, statement of the problem is that in the n equal to 3 state of hydrogen, find the electron's velocity, kinetic energy and potential energy. Okay, in the n equal to 3 state of hydrogen, find the electron's velocity, kinetic energy and potential energy. 3 things are required to be determined. Dear students, for finding these 3 things, we must first determine radius. Okay, so in other words, we have to find out 4 things. Okay, number 1 radius, number 2 velocity, number 3 kinetic energy, number 4 potential energy. Okay, dear students, in this problem several new tools will be introduced. Okay, some of those might be used prior to this video, and some may be new one. Okay, anyhow, we come to our solution, and before coming to our solution in a formal manner, we first visit our toolkit. Okay, toolkit, helping tools, tool number 1. Dear students, in this tool, Bohr radius is defined. Okay, Bohr radius and other radii in terms of A naught are defined. Okay, the radius of the innermost orbit is customarily called the Bohr radius of the hydrogen atom and is denoted by symbol A naught. Okay, yes students, when we say something as naught, it means we have used 0 or O or a circle like symbol which is usually used for degree. Okay, as a subscript of that letter. Okay, almost all these 3 subscripts may convey a similar sense, but in my opinion, the most appropriate letter is 0. 0 should be written as a base of that letter when we say or when we designate some physical quantity as naught. Okay, so here we have not called it as A, we have called it as A naught. So in the base of A, 0 is written. In place of 0, if we write O, then it may also convey almost similar design or similar symbol. Similarly, if we use a circle like degree as a subscript, then even then it may convey this sense. But in my opinion, the most appropriate thing is 0. Okay, so anyhow, this is just additional discussion, not very much related to our solution. Okay, so let us come to the point. The radius of the innermost orbit is customarily called the Bohr radius of the hydrogen atom and is denoted by the symbol A naught. Bohr radius A naught is equal to R1. Here 1 is written as a subscript of R, and 1 is because it is innermost. Okay, after 1 definitely 2, 3, 4, 5 will come, but this is because innermost, so R1 will be used. A naught is equal to R1 is equal to 5.292 into 10 to power minus 11 meters. Okay. The other radii are given in terms of A naught by the formula Rn is equal to n square A naught. Equation number 4.14. Actually, this snapshot has been chosen from the book Modern Physics by Arthur Weiser. Okay. Now we come to tool number 2, in which electron velocity is given, expression for electron velocity is given. This snapshot has also been chosen from the book Modern Physics by Arthur Weiser. Electron velocity V is equal to E, that is elementary charge over under root into 4 pi epsilon naught mr, where m is mass, r is radius, 4 pi epsilon naught has an other name which we call Coulomb constant or electrostatic constant. Okay, but it is just our discretion whether we use 4 pi epsilon naught or we use small k in place of it. Okay, so I think about electron velocity it is enough. But actually, while solving this problem's solution, we will take V square. Okay, V square will become equal to E square over 4 pi epsilon naught mr. Okay, under root will be eliminated, and we know that E square over 4 pi epsilon naught has a specific value from a table which will be included in our toolkit. Okay, so we will use that value and then we will enter other two remaining values. Okay, I think it is enough about tool number 2. Now we move to tool number 3. Tool number 3 deals about kinetic energy K. In previous tool, I had said that small k denotes Coulomb constant or electrostatic constant, which is equal to 1 over 4 pi epsilon naught, but it is capital K. Capital K stands for kinetic energy. Okay, so capital K is equal to half mv square and is alternatively equal to 1 over 8 pi epsilon naught E square over R. This is the expression for kinetic energy. Dear students, while solving this problem, here again we will apply methodology that we will convert it into E square over 4 pi epsilon naught, and remaining portion of this expression will be separated from this value, because we have a fixed value of this combined constant E square over 8 pi epsilon naught. Definitely this combined constant, that is E square over 8 pi epsilon naught, may have some specific name, okay, may have, but unfortunately it is not within my knowledge, okay. Perhaps it may not exist, or perhaps my knowledge is yet below this information, okay. So if some name exists for this combined constant E square over 4 pi epsilon naught, then in some subsequent problem or subsequent video I will disclose that name, okay. Anyhow, now we move to alternate version of this tool, that is tool number 3. Alternate version as well as first version has been chosen from some other book. For the time being I do not remember which may be this book. Probably it may be the modern physics by Raymond Moyer Moses, okay. Anyhow, even if it is some other book, it does not make any difference, okay. It is quite a separate discussion. So alternate version of tool number 3 says that for hydrogen, kinetic energy is equal to half MeV square is equal to half Ke square over R. Yes, exactly same as above, okay. What is the difference? The only difference is that here with mass E is written as a subscript, which means that mass of electron, okay. Moreover, in place of 1 over 4 pi epsilon naught, Coulomb constant or electrostatic constant small k has been used, okay. Remaining part is exactly same as in the first version of this, okay. Remaining part of this alternate version says that for other ions with 1 electron and Z protons, kinetic energy becomes equal to half Coulomb constant or electrostatic constant, which is equal to 1 over 4 pi epsilon naught into Z into E square over R, okay. I think it is enough. Now we come to tool number 4. Tool number 4 deals with potential energy, and expression for potential energy says that potential energy denoted by U is equal to 1 over 4 pi epsilon naught, which is Coulomb constant or electrostatic constant, sometimes denoted by small k, into Q1 Q2 over R. This alternatively becomes equal to minus 1 over 4 pi epsilon naught E square over R. Here it indicates that Q1 and Q2 are both charges, both elementary charges, but charge on them is opposite. And we know that when two similar signs multiply, their result is always positive, and when two different signs multiply, their resultant product is negative minus. Okay, so that is why in place of q1 q2 magnitude of charge is same, that is E, but uh, their nature is different, positive negative, so that is why here minus sign has come. Okay, anyhow, now we move to tool number 5. Tool number 5 deals with the total energy, that is kinetic energy plus potential energy. Okay, so above two equations have been added in this tool, and total energy finally becomes equal to minus 1 over 8 pi epsilon naught E square over R. Okay, next, problem number 6. Problem number 6, not tool number 6. This tool has been used several times, many times in our previous videos, and the most important quantity which will be used in our problem is this. Okay, E square over 4 pi epsilon naught is equal to 1.440 electron volt manometer or billion electron volt femtometer. Okay, moreover, I think other values will also be used. Let us see. Other values will also be used. Yes, other values will also be used. But the most important and main thing which is helpful is this combined constant E square over 4 pi epsilon naught, which may have some specific name, but up to my existing knowledge I do not know the name of this combined constant E square over 4 pi epsilon naught. Okay, that is E square over Coulomb constant, electrostatic constant, small k. Okay, dear students, here, yes, mass of electron, it will also be used, 0.511 million electron volt over c square. Okay, so when over c square will be used, then definitely this c will also be used, 2.998 into 10 raised to the power 8 meter per second. Okay, moreover, where E is being used here, this E elementary charge 1.602 into 10 raised to the power minus 19 coulomb, this may also be used, and perhaps some other, yes, Bohr radius A naught equal to 0.0529 nanometer, it will also be used. Okay, so this may also be used, 1 electron volt equal to this joule. Anyhow, now we move to solution in a regular manner. Okay, dear students, I had already mentioned that in our solution we have to find out 4 things. Okay, 3 things are required in statement, but one thing is a prerequisite for those 3 things, and that prerequisite thing is radius. Okay, so we have to find out 4 things: radius, velocity, kinetic energy, and potential energy. So first we come towards radius. Okay, So about radius, we know that A naught is equal to R1 is equal to 5.292 into 10 to power minus 9 meter, and Rn is equal to n square A naught. This implies that R3, because in the statement it is given that n equal to 3. State given is n equal to 3. So here in place of n we will use 3. R3 is equal to n square, meaning 3 square into 5.292 into 10 to power minus 11 meter. This becomes equal to 47.628 into 10 to power minus 11 meter. This becomes equal to 0.47628 into 10 to power minus 9 meter. Okay. Dear students, we know that 10 to power minus 9 is not very much important for us. What is more important for us is 10 to power minus 9 or 10 to power minus 12 or 10 to minus 15 or 10 to power minus 6, etc. Okay. So that is why we have converted this 10 to power minus 11 into 10 to power minus 9, so that in place of this we may use small n nano. Okay. So our radius R3 has become equal to 0.47628 nanometer. In our previous video, we have emphasized on this thing that where quantities are so small that they are in nanometer, then we should round that quantity, and the quantity after decimal should be avoided. But unfortunately, here all quantities after decimal. Okay. So at the most, what we can do, we can simplify it as 0.5 nanometer. Okay, that is about half nanometer. Okay. So what is the nutshell of my assertion, my point of view is that this value, that is 0.47628 nanometer, is quite okay, because it is the exact quantity which has appeared as a result of mathematical operation. Okay, but because nano is a very small quantity, so we can round it as 0.5 nanometer, that is half nanometer. But it is just a matter of discretion. I think it is unsafe. Okay, so this is quite okay. Now we come towards velocity. Dear students, we know that in our toolkit we had described velocity v equal to e over under root so and so, but here we have used taken square on both sides. Okay, so by taking square on both sides, it has taken this value, that e square over 4 pi epsilon naught has been separated, and remaining portion of v square has been multiplied as a separate factor, so that because we know the value of this combined constant e square over 4 pi epsilon naught. Okay, so this is a matter of convenience if we make this arrangement. Okay. So now we know that the value of this combined constant is 1.440 million electron volt into femtometer multiplied by into, in place of 1 over mr we will use this value. Okay, because this m is equal to, as per table which has been included in our toolkit, m is equal to 0.511 million electron volt over c square into, in place of r we have used that value, to which value we had assumed that it may be written as half nanometer. Okay, approximately. but here we have not used that pattern. Okay, we have written it in this form. Okay, now dear students, because c square is in the lower position of the denominator, so it will automatically, it will be shifted to numerator. Okay, so in the next step this whole thing will take this form. Okay, this form, this is just a simplification, nothing, no rocket science. Okay, now here dear students, because 10 raised to the power minus 15, so it should be converted to denominator and it will become plus 10 raised to the power 15 in the denominator. Similarly, 10 to power minus 9, which is in the denominator, should be shifted up or shifted to the numerator, and it will become 10 raised to the power plus 9, and then we will adjust these powers of 10 and our expression will be simplified. Okay, in the next place, dear students, in place of c square we have used its value in terms of meter per second. We know that c is equal to 2.998 into 10 raised to the power 8 meter per second, but here we have rounded 2.998 as 3.0, and square of 3 is 9, so here we have used, in place of c square we have used 9 into 10 raised to the power 16. Okay, because square of 10 raised to the power 8 is 10 raised to the power 16. Okay, meter per second will become meter square per second square because c is in square. Okay, remaining portion is this. Okay, so when we will simplify, it will take this form. Okay, okay, so further, moreover, when we will simplify, this will take this form. Okay, this is v square, but we are concerned with simply v. Okay, when we are concerned with v, then definitely we will take under root of both sides. That is, we will take under root of v square as well as we will take under root of whole this quantity. Okay, from here under root of 10 raised to the power 10 will become 10 raised to the power 5. Moreover, under root of this will become meter over second. Okay, okay, square will be eliminated and simply meter per second will appear. Okay, and under root of this will become 7.299. Okay, so hence velocity v has become equal to 7.299 into 10 to power 5 meter per second. Okay, we can round it as 7.3 into 10 to power 5 meter per second, but it is a matter of discretion. Up to this it is quite okay, quite acceptable. Now we come towards kinetic energy and potential energy. Now, kinetic energy is equal to 1 over 8 pi epsilon naught into E square over R. This becomes equal to, here E square over 4 pi epsilon naught will be separated as a independent factor because we know its value from our table. Okay, and remaining portion of this multiplying portion will be written as a separate. Okay, so in the next step, we, in place of this, we will use this value from table, and in place of this we will use value of R which we have calculated in the previous step. Okay, so kinetic energy K will become equal to this 1.512 electron volt because nanometer will be cancelled with the nanometer and our answer will be in electron volt. Now we come towards the potential energy. Potential energy expression for potential energy is minus E square over 4 pi epsilon naught into 1 over R. Okay, here in place of this we will use this value from our table. Okay, and here we will use value of R which we have previously calculated, and here nanometer will be cancelled with the nanometer, and our answer will become minus 3 point potential energy U equal to minus 3.023 electron volt. And this is the end of our problem, and this is the end of our video. Till next video, Allah Hafiz. Okay.